Hi everyone, my name's Jaisheel, and I'm here today to present on NgRx. But before I start with that, just want to see a show of hands. How many of you guys are still developing in Angular? Sure. I got worried there, like no one's doing Angular dev anymore. And so today my talk is on NgRx, and the logo looks very familiar. Richard, did you see it earlier? Yeah, so it's basically Angular and reactive JavaScript. It's not a framework, it's just a set of components and services that you can use within Angular. Angular 2 plus, so it works now with Angular 4 as well. And essentially it embraces the reactive principles that Richard talked about. And one of the core things you can do is sort of build a Redux-like application using Angular. How many people have done Redux? How many people have done Redux in Angular? Not so many, but what frameworks did you use for Redux in Angular? NgRx, okay, perfect. There is another one called ng2 Redux, but it's not as nice as NgRx. So we'll dive into it right now. With Redux, first of all. Oh, let me just start off. NgRx, as I said, it's a lot of components and services that you can use in Angular. Three of the main ones are NgRx store, which allows you to do Redux-like, follow the Redux-like pattern. Then there's NgRx Effects, which I'll also talk about. And then they have a cool NgRx DevTools, which allows you to use the Redux extension debugger. So anyways, to start off with the Redux pattern, essentially we have a view and it displays some state of your model. And that data is stored in a store. And if you want to alter the state in that alter that state, you would submit an action to a reducer, and the reducer would then mutate the object, or not mutate the object, but it would create a new instance of the object, and that would be stored in the store, and then that data is interpreted by your views to display in your view. So why do we want to use such a pattern in Angular 2? So with Angular 2, we have a lot of components, and you probably have like a root component, and then within there, inner components, and many other inner components. And one of the problems is that rendering these components every time there's a data change might be expensive. The reason I got to use this framework is we had quite a complex single-page application where we were having quite a complex model, and if you change data in one part of the model, it would then change multiple views. So for such a case, we found that because we actually ported our project from Angular 1, and we made some really bad design decisions, and we used $scope and shared it everywhere, and then we started using $watch, and we didn't really know what we were doing, and this seems much cleaner. So with Angular 2, they also give us the ability to configure or give us control of their change detection strategy. So essentially, you can actually manually configure a component to render only if you know something is changing. So you can basically optimize your front end a bit. So how do we do this? We start off first with a reducer. So reducer is a pure function, and if we look at this, can everyone read that? Otherwise I'm going to do that and make everyone shaky. Essentially, the function is the to-do reducer. It takes an initial state, and in this case it's just an empty array, and then an action gets passed in as well. And as a standard reducer, we're just switching on the different action types, and then we're using the spread operator and creating a new instance. Anyone want to tell me why the commented out code doesn't work? There's a nice JetBrains license. So why does the commented out code not work? Essentially, then we can use this data in our component. And Richard's talk was a good precursor to this talk. So with NgRx, everything is an observable. One of the core objects or injectable services that we use is the store itself. And what we do is we select from the store the to-dos object. I'll show you how we wire up this just now. But also, like if we want to add a new to-do, all we'd have to do is dispatch an action from the store, and we dispatch an action of type add, and then the payload is the string. Essentially, the front end is like this, where we've got a text box with a button, and if you click it, then it would add it to the list. And with the ng-for loop there, we're basically going to display the different to-do items. Because we're using observables, and we followed the convention Richard talked about with the dollar, essentially you use the async pipe so that it would actually then get the value from the observable. It wouldn't display the observable itself. So that's quite simple. And then how do we wire all of that up? So there's essentially we need to import the store module from NgRx store, and we need to call the method on the import to provide the store for root reducer, which I've defined here. And the root reducer is basically a mapping of what you're going to select from your state to the reducer that it should use. In some of the talks, they say you can sort of think of it as this is like each of the entries in the to-do reducer could be like tables, and the data in there are the actual rows. I don't know if that analogy makes sense to you. And it's also useful to make an interface for the app state, which the app state is essentially used here where when we injecting the actual store, we say that it has the app state, it's implementing that interface. So that's how we do the to-do app. So then another valid question is, that's very good, but usually our system is communicating with a lot of services, and these services are not in our normal code, or if we're doing like a backend system which can talk directly to the resources, that also can induce delays. So those are essentially all side effects for our application. And how do we deal with side effects? I mean, so traditionally in your view component itself, you could implement your, or call those various services using like HTTP for a web service, and then get the response, and then pass the data on to your reducer. But essentially, if you want to introduce a bit of separation of concern, you can basically bring the effects as a separate layer. So essentially what would happen then is, from your component, you would pass an action to the effects, and then the effects, after they actually make the call, would then pass the data to the reducer, and then manipulate the state of the application. And you can have effects across components, same way reduces across different, it's just manipulating state. So this is how you implement effects. You make use of the, you have to create an injectable service, and then you have to use the effect annotation. And in this case here, to add to do, basically actions is also an observable, implements observable, and an additional function called off type. And we're just checking if the type is save, then we map our action to basically a stringified JSON object, And then I'm making use of SwitchMap, which Richard covered in quite a bit of detail. With a really cool example, Richard. And after we get the result, we map the result into another action. And it's going to be of type add, and we're going to pass the actual object. So this is like in the to-do case here, where I'm actually going to save the to-do on the server, and I'm going to get the to-do object back, probably with an ID, because we're persisting it in the database. And what's important to note here, and it was a big gotcha for me, is the way I'm calling map and catch. So Richard mentioned in observables, you can just chain methods across. So the HTTP post is returning an observable, and then we're mapping that. But it's important to also do the catch there and not one level down, where about, like if you did the catch there, there's a problem where essentially this observable, this effect here, will unregister, and you'll notice that your effects are no more working. So it's just important that you pay attention to how you order the catch statement. So in there, I use SwitchMap, and there's another method called flatMap from RxJS. Here's the marble diagram Richard was talking about. And essentially, the function is if you get a circle in, after some time you get a diamond, and then after some other time you get a square. So if a red comes in, you get the diamond and square. If two colors come in very closely, you'll see that the, this is actually SwitchMap, that's flatMap. So with the SwitchMap case, it will only use the very last received observable, whereas in the flatMap case, it would do all of them. So it's just something to take note of. NgRx store-devtools. This is quite a cool plugin which you can use. And this will allow you to basically do that time travel debugging, which the guys who use Redux do. And I'll show you a little demo of that. Just before that, I forgot to mention something quite important with regards to that optimization. For NgRx store, when you want to only re-render the data if re-render the view if only there's data changes made. And essentially what you got to do is import this change detection strategy from Angular core, and then on the component annotation you say change detection strategy on push. So then because you know you're using the NgRx store, and your view should only be changed when the data changes. This is how it works. So it wouldn't work so nice if you passing data from different components down in a tree, because then the whole tree up would be re-rendered. So lastly, just the short demo of the NgRx DevTools. So that's a basic to-do app, and I'm just going to add something. And this is what the Redux DevTools plugin for Chrome gives me. So it's basically tracking all the different actions that I've submitted, and I can view the state at any of the given points. And that's my talk. Thank you.